Hello.
Hello. Good morning, Bitsy.
Good
Can you
morning,
hear
sir.
me?
Hello.
Yes. Hello.
Hello.
Yes. Good morning.
Good morning, sir.
Okay. So, can you hear me now?
Yes, sir.
So, as I have shared you the link, you have perhaps gone through that. I have
Yes,
already,
sir.
I've already assessed. I've already granted the access, that permission access also. So,
Yes, sir.
this
I
way,
got it.
I think it would be better that entire session you can go through the revision, and at the same time PPTs will be also there because already I am presenting the PPTs. So I think this would be
Yes.
helpful.
Okay, sir.
Yes or no?
Yes, sir. Yes, sir.
So let us start the today's session, continuing
Okay.
further. So just a minute. Yes. So before I start the today's session, let us have a very quick recap of the yesterday's session. And the yesterday's session, it was, we discussed about the different types of the coordinate systems, right?
Yes, sir.
And also we have seen the most important point is that how to transform the one coordinate system to the another coordinate system.
Another.
And in that, we'll have to remember the 6 7 formulas. Formula means you should know
Mm.
dot product of the unit vectors. Listen very carefully. You should know
Mm.
the dot.
Okay.
This you will have to remember. The dot product of
Okay.
unit vectors, and also you should know, and also you should remember, and even if you don't remember, but if at least this much you remember, that is the dot product. Screen is visible to you.
Yes, sir.
Yes. So even if you remember the dot product of the unit vectors, you can derive the those relations, these relations, because if you go, just I'm giving you these relations. So these relations are
Okay.
derived by help of the dot product of the unit vectors.
Mm.
Okay. So this you will have to remember. Otherwise, the question you won't be able to do. So how
Okay.
to convert the Cartesian to spherical, spherical to Cartesian. So there are questions in many books. Even I will share a PDF file also on your email ID.
Mm.
As you have
Mm.
mailed me, so I have got your email ID because there was
Okay.
email from you regarding the access of the Google Drive. So I will revert back
Okay.
a PDF in which the questions are also there solved. So
Okay.
you go through them and try to solve by your own. And if any
Mm.
doubt, note it down. Then you can ask me. You can share,
Okay, sir.
right?
Yes, sir.
So regarding proceeding from here, first we will have a very quick glance over this line integral, surface integral, and volume integral. These
Mm.
three integrals you must have heard previously also. Yes or no?
Yes, sir. Yes, sir.
What is the meaning of line integral?
Mm. Uh,
What is the meaning of line integral?
I don't know, sir.
Any idea? Okay, you don't know, it's fine. But always straight way, you should not say, I don't know. You should at least try, give it a thought. That what I have heard somewhere, You should try to recall what we were doing in it. At least for a minute, you should. And then you should come up with some answer. It may be right, maybe wrong. No thought?
Mm, no, sir.
No issue.
Means
So just let me give you the little bit.
we means are we doing it along a curve? Means line and then
Yes, not exactly line. The screen is visible to you, no? Okay.
yes, sir.
Okay. So just I will later on you go in the details using any good book mathematics because already you are writing GET, so you must be preparing mathematics also, right?
Yes, sir.
So
Yes.
there already you will be requiring these things because in mathematics it is required. So I'm just giving you a hint. See, suppose there is a function, any function f of x, it may be anything, and this need to be integrated over a path,
Mm.
and this path can be anything. Suppose this is the path, or this is a path, this is a path. So it can be anything. So as you can see here, so if I have to integrate it over a path, right? So
Mm.
it may be the direction is specified, the limit is varying. So it is the line integral, means over this line from here to here. If I call it as A, B, C, D, then A to B, B to C, C to D, like this. Okay, if I call
Mm.
it
Mm.
as A, B, C, D. So integral over the means they represent like this. Integral as usual. Fx, if it is a vector, that dl. So this dl, and here we specify the path. For this example, it is path A, B, C, D. And if I write A, B, C, D, A, then it is a closed path. Means we are
Mm.
starting from A and we are coming back to A. So in that case, this
Mm.
A, we represented this like encircled. That means it is over the closed path.
Mm.
Is it clear?
Yes, sir.
Yes. So A, B, C, D, A. So this can be represented as, this you must be knowing, that integral of f dot dl over AB plus
Plus BC plus CD plus
BC, means B to C, plus CD,
C2
and if we are going for the close, then again we will come to D to A.
to A.
So this you must be knowing. Yes?
Mm. Yes, sir.
Yes. So this is the meaning of the line integral over a contour, over a path.
Mm.
This word you must have heard, contour. So over a contour or over
Mm.
a path, this is called as contour. So over a contour or a path, we integrate the function. So the line
Mm.
integral. So line integral very simple. Suppose as you can remember in the Cartesian, spherical and cylindrical, we have studied the expression for dl. So for example, the
Mm.
simplest one is the Cartesian. So there we used to write dx ax. Yes, yesterday we have written
Yes, sir.
dx ax plus dy ay
Yeah, right.
plus dz dz.
Yes, sir.
Yes.
Yes, sir. Yes, sir.
So here just you will have to integrate this with respect to dx, with respect to dy, with respect to dz, and you will add the final result and you will get your answer. So this is called as line integral is a single integral. Single integral means one integral. This line integral is called as this single integral. Okay, is it clear? Hello? Hello?
Hello?
Yes, hello.
Hello?
Yes, can you hear me?
Yes, sir. Yes, sir.
Okay. So in meanwhile, perhaps it got disconnected. Okay,
Okay.
this is some reason. So this is what I was discussing. That line integral is a single integral, right?
Mm.
Then we come to the then we come to the surface integral. This is important, again very important. Surface integral. What is the meaning of surface integral? Can you tell me?
Integrating over the surface.
Integrating over the normal surface area. That is very. So if I am again see if I am having the f of x any function, and then we integrate this with ds n cap means normal surface area. Yesterday also I told you that the area element which we are taking is the normal surface area. So here
Okay.
be very careful that which component, because see, for example, it is Cartesian. Yesterday already we have seen that there are three possible expression: dx, dy, az.
Mm.
Yes or no?
Yes, sir.
dy, dz, ax.
D Z A X.
Yes or no?
Yes.
Yes. And then what will be the last one? Tell me. dx,
DX DZ
dx,
DZ
dz, ax. This is
Y.
called Cartesian. In cylindrical it will change, and in spherical also it gets changed in terms of rho, phi and z. In spherical it gets changed in terms of r, theta and phi. Uh, wait. Hello?
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 Hello? Hello? Oh,
Oh, yes, actually due to the call on mobile it got disconnected.
okay. Okay, sir.
So regarding the area, this is what I was discussing, that if I'm having a function f of x, so then we integrate it with ds. So this is ds n cap means normal component of the area, right? So normal component, as I told you that for example, if it is the normal to the x plane, so if it is normal to the x plane, then you will write dy dz ax. Yes or no? You
Yes,
will
sir.
have to see the problem in the problem that your element is lying in which plane, and accordingly you will choose your normal component of area, because there are
Okay.
three possibilities. Ax component is different, ay component is different, and az component is different.
Mm.
So accordingly you will have to choose. And one more important thing here, it is dy dj. So you can see here this will become the double integral. The function will be integrated with respect to dx, and the function will be integrated with respect to dy, or maybe dy dz, or maybe dx dz. So always it will be double integral. Surface integral is always
Okay.
the double integral. Is it fine?
Yes, sir.
Yes. This you must have studied. Just I'm trying to recall these things. Then third is triple integral, volume integral. So this you already know, volume integral. What is the meaning of volume? See, volume is dx, dy, dz. Yes or no?
Yes, sir.
So of course, this is see, this is the triple integral.
Okay.
The so the function will be the x. It will be this integrated with dx. Limit will be there. The dy with dz. Yes or no?
Yes, sir.
Yes. Any question?
No, sir.
So, so this is what you can see. A dot dl, this n circle is for the close. Here also I can put an, if I put an n circle means this is the closed integral. But see, I'm writing a single integral s, but this means that this is a double integral. If s is there, means it will be a double integral. And if I'm
Okay.
writing the v, means it is a triple integral.
Mm.
I hope it is clear. There is no
Yes, sir.
doubt over it. Then, a topic to be discussed today is del operator. Are you familiar with this del operator?
Yes, sir.
What is this del operator?
I just know that dou by dou x AX.
Yes. See, this
Uh,
del operator is defined as delta over del x ax plus delta over del y ay plus delta over del z az in Cartesian coordinate system. In cylindrical coordinate system, it is delta over del rho a rho plus 1 by rho times del upon del phi a phi plus del upon del z az. In spherical, it is del upon del r a r, 1 by r times del upon del theta a theta, and 1 by r sine theta times del by del phi a phi. Now, what is the meaning of this del upon del x? Yes.
mm.
What is the meaning of del upon del x? Are you there?
Yes, sir.
Yes. So, what is the meaning of
Del-
del upon del x?
It's partial derivative.
Partial differentiation. Yes.
Uh,
Differentiation of the function with respect to x only,
X.
whereas other variables are supposed to be constant.
Constant.
Similarly, here the partial derivative of the function with respect to y, whereas the other variables are supposed to be constant, and here the partial derivative with respect to z, keeping the other variable constant. Here, partial derivative with respect to rho, keeping the phi and z constant. So, likewise, I hope it
Yes,
is
sir.
clear.
Yes, sir.
So why this del operator is necessary? See, what we are going to study now, we are going to study the space derivative of scalars and vectors. There are two physical quantities, either it can be a scalar or it can be vector. So we are going to see that how we can find the space derivative of scalars and vector. So there are three basic operations with the help of this del operator which we use to find the space derivatives of scalars and vectors. So this
Okay.
the space derivative of a scalar, first we will talk about the space derivative of a scalar, is given by gradient. This is called as the gradient of a scalar. The space derivative of
Okay.
a vector can be found by two operations. One is the divergence, another is the curl. So three things we have to study. One is the gradient, another is the divergence, another is the curl. All these three are very, very important, as you will see that questions have been asked in the previous past years from these topics. I will show you. First you understand.
Okay.
Do you have idea about this already, or this is, you know
Uh,
these things?
I forgot this, sir.
Okay,
I
so
remember these words, but I forgot
okay,
this.
so just have the idea at least. What is the meaning of gradient? See, gradient gives the rate of change of a scalar quantity. Listen very carefully because it is always operating on a scalar, not the vector. So the gradient gives the rate of change of a scalar quantity in a particular direction. Now what I mean to say by this, let us suppose an example. Suppose you are sitting in your room right now. There is
Mm.
some temperature in your room right now that may be
Yes.
cold, maybe 20 degree, for example, say right now.
Mm.
After an hour, as the sun will go on shining brighter and brighter, the temperature of your room will change. Yes or no?
Yes, sir. Yes.
But suppose I ask that in which particular direction of your room there is maximum change.
Okay.
So what I'm asking is that, okay, change will be there. Maybe it may increase or may decrease also due to the cloudy weather. That is not a problem. Change will be there in the entire room, but there will
Mm.
be a maximum change in one particular corner or one particular direction of your room. Because suppose
Yes.
window is in the east, then the most of the sun rays, if they are coming from the window, that is the from east, then of course in that direction temperature will be little bit different in comparison to the other corners of the room. Yes or no? Hello?
Hello? Mm.
So this is what I am asking. That suppose
Okay.
that window is in the east, then
Mm.
if the sun rays are coming from the window, then of course in that direction the temperature of the room will be slightly more in compared to the other corners of the room. Yes or no?
Mm. Yes, sir.
Yes. So this is what I'm interested that what is the maximum rate of change and in which direction. So that is given by the gradient. So, but of course,
Okay.
gradient is operating on the scalar, but since I am interested to know the direction in which the maximum change is there, so resultant will be a vector. Be careful, resultant will be a vector, the output will be a
Okay.
vector.
Okay.
So as you can see here, suppose
Okay.
the temperature at the point P is known xyz. At P2 it is x plus dx, y plus dy, z plus dz. That is what I said. So in this, so this is a
Mm.
vector, see. So it is varying in this direction. So this dl, we know that dx ax plus dy ay plus dz az. So dt, that is change in temperature, is T2 minus T1. So see, delta of dt upon delta of x dx plus delta of t del y dy plus delta of t del z dz. And see, very important, this expression delta of t upon del x dx, delta of t upon del y dy, and delta of t upon del z dz. What is this? This is, this signifies what? This is represented, this is a representation of which mathematical identity?
This is del operator.
This is dual operator, but what I am asking is that as we are writing like this, so okay,
Ah.
yes, do you want to say something?
No, no.
Okay, good. Now see, what I was trying to ask, dx, if you see, dx is what? dl is dx ax plus dy ay plus dz az. If I take with the dot product, ax dot ax is 1 and rest all other dot product will go to 0. Yes or no?
Yes. Yes.
Similarly for dy, I will take the dot product with ay and rest all other dot product with, will go to 0.
Yes.
Here also, then I can replace
Mm.
the dx with ax dot dl. I can replace the dy with ay dot dl, and I can replace the dz with a dot az dot dl. Yes or no?
Yes.
So see, the final expression is del t upon del x ax plus del t upon del y ay plus del t upon del z az dot dl. And this part, this is what I was actually trying to ask. This part is nothing but this is represented as this del operator, sorry, this part is represented as the del operator t. Delta of t means differentiation of t with respect to x ax, differentiation of t with respect to y ay, plus differentiation of t with respect to z az. Yes?
Yes, sir.
And this is also called as the gradient of the temperature, delta of t. So this is what the, so see, here the final answer. Del V, here we are using the V, T or V, it can be any variable. So, so delta of V, so this is called as grad of V. There is no, the important point to be noted, there is no operator here. There is no dot, no cross. Only we are writing grad of V. This V is a scalar. So delta V upon del x Ax. So of course Ax, Ay, Az are there. So it will be a vector. So V is a scalar, but if you take its grad, it will be a vector. Am I clear?
Yes, sir.
Any doubt? See, try to understand this one.
No.
It would be a problem. I'm giving you just a little bit idea. You may go through the later on, but thing is that you should be able to solve the problem. And problem to solve the problem, you should know this one.
Okay.
Yes.
Yes, sir.
Then again, you will have to remember the formula for circular coordinate del v upon del rho plus 1 by rho. Be careful. Here it is 1 by rho divided. And then if I, of course, del v by del z, here it is 1 by r is divided. So, and here it is 1 by r sine theta is divided. So, these factors you need to take care while remembering the formula. Because these are the extra factors. Otherwise, rest it is similar to Cartesian. But these are the extra factors. Yes or no?
Yes, sir.
Yes. So this you will have to remember. Okay. So gradient is over. Now we come to the space derivative of vectors. So there are two operators, the space derivative of the vectors. One is the divergence, another is the curl. Do you have any idea about the divergence of a vector? Okay, one more thing, important point here. If suppose you calculated the gradient and this appears to be 0, this comes out 0, then such function is called as equipotential function or equipotential surface. So in the examination, sometimes question may be asked, a function may be given, and it may be asked to check whether the given scalar function is an equipotential function. So what you will do is that
Okay.
you will find its gradient, and if it comes to 0, then you will say that yes, it is an equipotential surface.
Surface.
Yes?
Yes, sir.
So remember this, if the gradient of a function is 0, then function is called as
Equipotential surface.
equipotential surface. Okay. So you may try these questions by your own. Find the gradient of these scalars. So for this, just you need to know the differentiative, that is the derivative of these functions. The cos h means hyperbolic. So cos hyperbolic y. Here it is in terms of the cylindrical coordinate system. You can see the rho and phi, and here it is r, theta, and phi. So, but of course, here it is spherical coordinate system. So, would you be trying it by your own?
I will try it by my own.
Try it. So, solution here it is given, but it would be better if you try it by your own. Then we come to the divergence of a vector. What is the meaning of divergence? See,
Diverge means
divergence means, see, let me give you a very first simple example, then I will come to this mathematical part. See, suppose there is a pipe, right? From the pipe, it is having the two ends. One is the inlet end, one is the outlet end. Yes?
yes, sir.
So see, suppose from inlet end, the amount of water which is entering and if the same amount of water is coming out, right?
Mm. Yes.
So we are measuring that how much amount of water is coming out. So means if suppose
Mm.
the same amount of water is coming out, means it is not diverging from its path.
Okay.
This is what is the meaning of divergence, is that outward flux, how what amount of flux is coming out from a given body or substance, anything. So this is what means, how this it is diverging. So this net outward flux which is coming out is called as the divergence. So this is what the divergence gives you, the measure of a field or flux which is flowing outward from a given unit volume. So this you should
Okay.
remember that here div, of course, divergence short form div. Here important point is this one. If you see the expression, previously it was del A. Here it is del dot A, and this A is a vector. As as I told you that whatever is a dark, that is a vector. So this A is a vector. This is not a scalar. This is a
Mm.
vector. But
Mm.
very surprisingly, output is a scalar. This is a very, very big difference between the gradient and divergence. In gradient, input is a scalar, means that operates on a
Mm.
scalar, but gives you the vector. In
Mm.
divergence, it operates on vector, but gives you scalar,
Scale up.
right?
Yes, sir.
So del dot A, first understand this, that how to find the del dot A, because that is only needed for you. So this is the derivation. Main thing is this one. Del dot A is partial derivative of ax. Please be very, very careful. Not a.
Mm. Mm.
Only
Mm.
x component of a is to be differentiated with respect to x. Only y component of a. Are you getting my point? Not whole
Yes,
a.
sir.
Only y component of a is being differentiated with respect to y, and only z component of a is being differentiated with respect to z.
Set. Mm.
Is it clear to you?
Yes, sir.
Similarly, only row component but multiplied with row. Again, you need to be very
Mm.
careful
Mm.
here. Row is multiplied, then row arrow is differentiated with respect to row and divided by 1 by row. So this 1 by row
Mm.
is multiplied with this quantity. You take the
Mm.
partial derivative of this and multiply with 1 by row. Again, you take the partial derivative of this and multiply it with 1 by row, and this is of course del z by az. This is for the cylindrical. You need to remember this. Time and again I am saying, because questions will be from here. You need to remember it. Then last is the spherical coordinate system. Again the same. R square AR. So first you multiply with the R square with this AR. Then you take its partial derivative. And then you multiply with 1 by R square. Then
Mm.
A theta sine theta. You see. So you multiply with the sine theta to the A theta component, right? And take its partial derivative with respect to theta. And then you multiply with 1 by R sine theta. And here is of course 1 by R sine theta is multiplied. So this you will have to remember.
Mm.
And also you will have to practice. Okay.
Okay, sir.
Then one more conceptual point. Let me go back. There is actually one slide here. One more conceptual point is here, that divergence can be either zero, positive, or negative. So understand this. What is the meaning
Mm.
of zero divergence? What is the meaning of C? As I told you, that divergence is outward flux coming out of a surface. So you see, this is a surface. Is there any
Mm.
flux coming out of this surface?
No.
No. So see, divergence is zero. This is an example of zero divergence. Means nothing is coming out. So this is an
Mm.
example of zero divergence. Is that clear?
Yes, sir.
Now what is the meaning of negative divergence? You see, here nothing is coming out, rather everything is inward, nothing is outward.
Mm.
This is the condition for negative divergence.
Okay.
And positive divergence, but obvious, see, it's all going outward. So this is an example of positive divergence. So these three figures are clear to you. What is the meaning of negative
Yes, sir.
divergence, positive divergence, and zero divergence? Is it clear?
Yes, sir.
Yes. So if it is clear, then again you can practice for your own. That is, find the divergence of this vector. This is in the Cartesian coordinate system. This is in the cylindrical coordinate system. This is in the spherical coordinate system. So again, formula is del dot p. If you will start solving, then you will write del dot p is equal to
X,
del px. What is px here?
px is x square yz.
Yes, so this you will have to differentiate with respect to x. So what will be the value of this del px upon del x? Tell me verbally. What will be the value of del px upon del x? Because this you have to find. So what will be this value?
2xyz.
Of course. So here you will write. Then you will find del py. What is the value of del py? This what is the value of py?
X is it?
Py.
Y. Okay, py 0.
Zero.
0.
Pz is xz.
X
And
is
what will be the del pz upon del z?
it will be x.
X. So then final answer will be 2xyz plus x.
X.
So this one is solved. Similarly,
Yes.
to apply here, what is the
Okay.
q rho component?
Rho sine phi.
Yeah. So likewise, you see the formula, practice it, find it. Then, as we have studied that if the gradient of a function is zero, that is a equipotential surface. If the divergence of a vector is zero, that vector is called as solenoidal vector.
Okay.
Which vector? If it is zero, then it is called as. If the divergence of a vector is zero, then it is called as. Tell me. Then it is called as solenoidal vector.
Solenoid.
Okay. Remember this. I don't know whether perhaps I have missed it
Okay.
out to mention here, but remember it.
Yes.
That is called as solenoidal.
Solenoidal vector.
Yes, that is called as solenoidal vector. SOLENOIDL. That is called as solenoidal
Solenoid.
vector. It's important. So if you have to check whether a given vector is oh sorry, here it is there. Divergence of a vector field. If it is zero, this field is called as solenoidal field or vector.
Field.
The same thing. Clear?
Yes, sir.
Yes. The last is the curl. See, in gradient, input was a scalar, output was vector, right? In divergence, input was vector,
Vector.
output was a
Output
scalar.
was a scalar.
In curl, input is vector and output is also vector,
Vector.
right?
Ah.
First thing. Then the gradient you represented like this, grad of f. The divergence you are writing like del dot a
Del dot.
dot a. The curl you are using the same del operator. You are writing it like del cross e or a. What it is? Cross main thing is, see there's three expressions. Here it is nothing is there. Here dot is there, dot product. Here it is a cross is there, the cross product. So, but of course, dot product, you know that dot product is always a scalar product. Yes or no?
Yes, sir.
And cross product is always a
Vector product.
vector. So here it is with the help of del operator, we find that here it is the vector, here it is scalar, and here it is both vector. Input is also vector, output is also vector. Right?
Yes, sir.
So we will see the formula, but before that, what is the meaning of curl? So you see, At least this much you know. You should know. This is an rotational vector whose magnitude is the maximum circulation of A. This is the important point. This may be asked or this may be helpful. The maximum circulation of A per unit area. So whether your vector can be circulated or not, this is determined by curl. So that is why it is said that suppose curl of a vector is 0, means that vector is irrotational vector, because this is giving the maximum
Okay.
circulation. So if curl is 0, means circulation is 0, means vector cannot be rotated, or in other words, that vector is also called as conservative field. Conservative field.
Okay.
In classical mechanics plus 2, you must have studied about the conservative and non-conservative field and forces. What is the meaning of conservative field? If I say that any field is a conservative field, what is the meaning of this?
Mm,
What is the significance of this? If I say any field is a conservative field, what is the significance of this?
mm,
Conservative field means work done is independent of path. You should know these things because
Okay.
later on, if a field is conservative, means it's of course its curl will be 0, and the second important point is that work done will depend only upon the initial and final position. Means if something is being moved from here to here, have to do the work. So I can go from this
Mm,
A to B by any path. If it is A, this is
mm,
B. I can go from here to here like this also, like this also. But if this field is conservative, then this will depend only on the initial and final position, not on this path. But if it is
mm.
non-conservative, then for different path, there will be different amount of work.
Okay.
Did you get the point?
Mm. Yes, sir.
Yes. So this you should know. Otherwise, because later on also it will come into picture. So this is giving
Mm,
you this circulation. So now how to represent the curl? The formula is actually important here. Again, see, this is determinant. I hope you must be knowing how to evaluate a determinant.
uh,
Yes or no?
Yes, sir.
Yes. So Ax, Ay, Az, of course, Cartesian. Here it is del by del x, del by del y, del by del z. Here it is x component, y component, z component. And then you can evaluate
Mm,
the determinant. So if you remember this, very easily anybody can evaluate the determinant.
mm.
I hope you must be knowing. We take
Yes,
this
sir.
one, then we remove this one and this one, then this into this, minus this into this. Then if you take minus ay, then you remove this one. Yes, we evaluate the
Mm.
determinant
Yes,
of
sir.
this. Yes,
Yes.
this one is being removed, then this into this minus this. So determinant you must be knowing. This is expected at least. Okay.
Yes, sir.
So just again, the two more formulae will be there for circular. It is same determinant, but important point here is the 1 by rho is multiplied. Here rho is multiplied. So while here also rho is multiplied. So while
Mm,
expanding, this factors should be there. Here it is rho a5.
mm,
Here it is rho capital A5. Here it is 1 by rho. And just you will have
mm.
to expand your determinant. Any doubt?
Okay. No, sir.
And as I told you that if the curl if the curl is 0, then it is irrotational field. Irrotational. So
Mm,
condition you should
mm,
remember for an irrotational field, the curl is always 0. For equipotential surface, gradient is always 0. For solenoidal field, divergence is always 0. And for irrotational field, curl is always 0.
mm.
What is the condition of
Yeah.
solenoidal field? Bitsy?
Uh, Divergence is 0.
What is the condition of irrotational field?
Curl is 0.
And what is the condition for equipotential field or equipotential function?
Gradient is 0.
So this you should remember.
Mm,
So again, for a spherical coordinate, it will be same, some changes. R will be multiplied here, R sine theta multiplied here, and with the whole it is multiplied by 1 by r square sine theta. So you will expand the determinant and you can find your answer. Yes.
Okay. Okay, sir.
So, and just for your practice, as usual, again here you take in determinant form, put the values, expand the determinant, find the curl.
Mm. Mm.
Yes.
Yes, sir.
Okay. Now comes the actual crux. Yeah. The last two topics. Stokes theorem. Very important. Very important. Throughout the next topics, electrostat, we will be using this. So understand it. What actually is happening? Stokes theorem.
Mm.
See, the Stokes theorem. It says that A dot dl, if you see, this is a line integral over a closed path, left hand side. If A is a vector, then the closed integral, this line integral over a closed path, is it left hand side?
Yes, sir.
And
Yes.
see, this is equal to the surface integral of not the vector, rather the curl of the vector.
Mm.
See very carefully. As we have studied the curl now, so we can understand. This is see del cross A. So here it is A dot dl means line integral of a vector is equal to the surface integral of curl of the vector. Are you getting my point?
Yes, sir.
And another important point here you this, see this circle is there, means this is a closed path, and here it is the open surface.
Okay.
Very important. That
Mm.
so a statement you should know. Sometimes question may be asked in some way they twist the statements or the expressions. So the Stokes theorem, basically you can say this is a theorem which gives the relation between the surface integral and line integral. First important point. Second important point is that line integral of a vector over a closed path. Listen very carefully the statement. Line integral of a vector, it may be a, b, any vector, of a vector over a closed path is equal to the surface integral of the curl of the vector. Surface integral of curl of the vector. You first take the curl, then take its surface integral. So surface integral of the curl of the vector over the open surface bounded by the closed path. This is the total and the exact statement of Stokes theorem.
Bounded by a closed path.
Yes, bounded by means if I'm having an open surface, something like this, then this should be bounded by this closed path.
Okay.
This is the surface and this is the closed path.
Hmm.
Yes?
Uh-uh.
So this you should be very careful. That line integral of a vector is equal to surface integral, but not the directly surface integral, rather curl of the surface integral of the vector. Any question here?
No, sir.
I think something is there in your mind. You may share it if it is anything, because your sound is little bit sounding doubtful.
No, sir. Surface integral of curl of the vector over
The surface integral of the curl of
curl of
the
the vector.
vector over a open surface bounded by closed path.
Okay. Hmm.
Clear?
Yes, sir.
This would be needed. So please understand this and later on go through the other material, whatever the notes you are having, AES Academy or any book. So this is, but this much at least you should know this expression and how we are converting the line integral to surface integral. Yes,
Yes, sir.
and then another is the Gauss divergence theorem. Slide I will send you. Okay, the Gauss divergence theorem. Perhaps I have Did I miss to put the Gauss divergence theorem? Okay, but I will explain because that is very, very important, just like this. No, here it is there. I have missed the slide. Here it is there. Also known as divergence theorem. Again, you see very, very carefully. Here, this side, left hand side, it is volume integral. Sorry, this is written incorrectly. Sorry, let me correct it. This is incorrect. Here it should be surface. This is the surface integral, A dot ds. And here it is fine. So you see, this closed surface integral is equal to the volume integral of, see, the volume integral of divergence. This del dot A is what? This is divergence. So is equal to divergence of the vector, means the volume integral of divergence of the vector over open volume bounded by closed surface.
Okay.
So Stokes theorem gives you the tool for converting the line to surface, and this gives you tool for converting the surface to volume. Is it okay?
Yes, sir.
Once again, I'm repeating that divergence theorem or Stokes or Gauss, this was given by Gauss, so also known as Gauss divergence theorem. This states that surface integral, you see here, surface integral of a vector A, it may be any vector, a surface integral of a vector A is equal to volume integral of divergence of the vector over the open volume. This is open volume over a closed surface. Shall I repeat again?
No, sir.
So this you can, I will send you the slides. You can see the derivations also. Here it is there, that how it has been verified. This has been verified. So right. So after completing this, just a few more minutes I will take, and I will give you a glimpse that what is the importance of this chapter related to GET, because your goal is GET. You have joined this session for that. See, this question, this was asked in 2009 for the 2 marks. Go through the question.
Vector field B is related to another vector field A through V vector equal to del cross A vector, which is the following is true. Note C and SC refers to any closed contour surface whose boundary is C.
See, I am giving you the hint.
Okay.
This is related to what we have studied just right now, that is the Stokes theorem. So they have asked Stokes theorem, but not directly
Okay.
application of Stokes theorem. And this is 2 marks. See, 2 marks is good one for a GET. If somebody solves for it correctly, this is having importance. Can you give it a try?
Yes.
Okay, right now actually you cannot give it a try because first you will have to go through all the things. Just I've shown you that how the questions are being asked. One more, here you go through the question. And at least you can tell me that what you will do here. Again, see, 2015 2 marks.
Okay.
Go through it.
Vector B is given by P vector equal to x cube y ax minus x square y square ay x square y z a z.
So what you will do? At least you just tell me what you will do. Later on you try it. What you will do?
We should find divergence and curve.
Yes, you will find the divergence and curl. And if you get both 0, then it is solenoidal and irrotational.
Solenoidal and irrotational.
If divergence is 0, then it is solenoidal but not rotational. If only curl is 0, then it is
Irrotational.
a rotational but not solenoid, and suppose both are not
Yes,
0, then this should be the correct
yes.
answer.
Oh,
That's what. That's why while teaching, I told you that very important. Sometimes they are asking the question,
mm,
not very back, 2015, they asked it for 2 marks. 2 marks
mm,
because calculation would be there. You will have to calculate both divergence and curl.
mm,
And curl, you will have to evaluate the determinant. So it will
mm,
take some time. But it is very easy, is not it? Once you
mm.
find the both the curl
Yes,
and divergence, very easily you can select your answer.
yes.
Yes or no?
Yes, sir.
Yes. So a easy one. Next one also, this is nothing but you see, surface integral. So this you should learn, only 1 marks, but surface integral you should learn that how to integrate the surface integral.
Mm,
So it will take some time. So let us do one thing. See, almost the first, as I had shown you the yesterday, this one, by this slide, that how I have designed my course module. See, teaching would be fruitful only if, so this part I have covered, right? Coordinate
mm,
systems and vector
yes, sir.
calculus. Okay?
Mm, mm,
Now let us do one thing. You take your time this week, go through the
mm,
as much as problems you can, including all those
mm,
get problems and some other variety of related to that which are of the
mm,
get level. And
mm,
remember the formulae, conversion, formulae of gradient, scalar,
mm,
divergence, curl in all 3 coordinate systems. And then next we will meet on Saturday. I want to give you the full
mm,
time that you take your time so that then only it is useful. Otherwise it would be the wastage of the time and money both. So then we will meet
okay.
on Saturday. You come up with some
Mm,
doubts, and then if there is no doubt, then we will proceed with the electrostats. This is
yes,
what
sir.
my strategy. If you think
Yes.
differently, you may share it. Then we will see what can be the best possible option.
No, sir, we can do like that.
Sorry?
We can do like that on
Yes.
Saturday.
So if you want to go with this, you may go. And if anything else is in your mind that no, I would not like to go this, I would like to go by this, then you may share. Then I will see that yes, whether it is feasible or not. So I
Oh,
think 5, 6 days should be there for you to solve the questions.
yes.
And
Mm,
yes. So, okay, fine, we will end the session. The
okay, fine.
first, this is what I was looking at least this much I should be able to complete this week. Next week, because see,
Mm,
once you understand these things, this will become easy to understand the
mm,
electrostats system. So very easily we would be able to cover the most of the syllabus by Jan 10, 12 or maximum 15. This is what I'm trying. But here it will
mm,
take
mm,
time to understand the things. Coordinate system.
mm,
As I showed you that
mm,
one question, 1 mark, but that is totally related to the understanding of this surface integral. This is nothing. Only you have to integrate the surface integral. Nothing else is
mm,
1 marks. Here already I told you. Here the one question is related to the Stokes theorem. So you will have to go
okay.
through these things very rigorously, and this will be used. Here they are direct questions. I will show you the many more questions where the application of the Stokes and Gauss divergence and this coordinate system is there in magnetostats,
Sir,
electrostats, and all that.
uh,
Yes,
is this answer B?
which one?
Its answer.
Uh,
Is it B?
first one. First one I will have
Ah,
to
no.
check
No.
if a vector v is related to the other field A through v is equal to del cross A. Which of the following is true? So A dot dl is B dot dl. No? Yes, yes, exactly. Exactly.
Ah,
Yes.
okay.
Answer would be B. So see, once you understand, it's very easy. Okay.
Sir. Mm, okay, sir.
Okay. So
Okay.
we will meet on Saturday. Solve. Yes.
Okay.
In meanwhile, if you are having any problem or you need any
Mm,
support or any resource, you may call or may send your queries on the WhatsApp. That's not a problem.
okay, sir. Mm,
For the class, we will meet on Saturday 5:30. Fine.
okay.
Okay.
Yes, sir.
Thank you. Have a good day.
Thank you, sir. Okay. Thank you.